We have spent a few weeks talking about big data to give you a good foundation about all of this data that people collect, the importance of that data, and the importance of data analytics. Now that a good foundation is built, we can shift our focus onto data warehousing and defining what a data warehouse is. The similarity in some of these terms you are learning can be a bit confusing at first, which is why I have taken a more methodical approach of stepping through the big pieces of this concept. Simply put, a data warehouse is a relational database that stores all of the big data we already discussed, but unlike most databases that you have encountered that are used for transactions, a data warehouse is designed strictly for query and analysis. For example, an airline company has a large database that contains all of the current and upcoming flight information. This database is accessed by travel agents, airline employees, and everyday customers, all of whom are looking for flights to a particular destination. The users of these databases are able to not only query, but also make changes to the data by establishing reservations. This is a transactional type of database because it allows users to conduct transactions. They are designed to allow for thousands of current connections and thousands of transactions every second. On the other hand, a data warehouse is designed for a different purpose. Data warehouses are not used for transactional purposes. It is designed to be used only for running queries against the data it contains and to perform data analytics. I mentioned at the end of the last lecture that the analytics happen inside of the data warehouse. This is what I meant by that. It's important to draw the distinction between what I refer to as everyday databases, which are the transactional type, and the data warehouse. They both have a purpose, but the purposes are distinctly different. So why have two different designs? Well, the answer is actually simple. A data warehouse needs a lot of computing power to maintain such a large relational database, and even more juice to analyze the data it holds. Organizations that use data warehouses don't want their precious computing resources used up by users trying to conduct everyday transactions. And speaking of transactions, it would be hard to conduct analysis on a data set if the data kept changing as users conducted transactions. The results of analysis in this situation would be unreliable. So we keep these types of databases separate from each other, and we keep the everyday users from accessing the data warehouse. By doing this, we can devote all the system resources to arranging and analyzing the data so that we can achieve the results we discussed in the previous lecture. If we try to have a data warehouse that is also used for regular transactions, then we will split these resources and make it more difficult for the analysts to do their work, and also more difficult for the users to conduct transactions. Of course, much of the transactional data will end up in the data warehouse so that there is a constant flow of current data coming in. This can happen in a variety of ways, but the data is typically uploaded from a transactional system, either manually or through an automated process. But a data warehouse can get information from many other sources as well. It doesn't have to just be limited to the contents of one transactional system. Many organizations have several different transactional systems that feed into one data warehouse. In fact, you could say that the more data available to put into the warehouse, the more analysis you can do, and the greater likelihood of more accurate results. If we use Facebook as an example again, with such a large user base, they have data centers and servers located around the world to support the ever-growing use of their site. All of the data at these locations has to get pushed up to a central data warehouse, or maybe a few different data warehouses, in order to conduct the needed analysis. So they are pulling data from multiple locations in order to get centralized analysis. Google does something very similar, and if you search the internet for Google or Facebook data warehouses, you will find a little bit of information on the capabilities that they have. These are great examples because there probably isn't anyone else on the planet storing as much data as these two companies. And if we want to see where data warehousing technology is headed in the future, These are the two companies to watch, and maybe even copy. Using a data warehouse has many benefits. First, as we already touched on, they have the ability to combine data from multiple sources into a single database so that single queries can be used on all the data at once. They give us the ability to maintain historical data, and because of their storage capabilities, they can hold much more historical data than transactional systems. Data warehouses restructure data to improve query performance, especially in the case of the more complex queries that are often run against this data. The restructuring also presents the data in a way that makes more sense to business users. Data warehouses are able to eliminate a common problem that occurs in transactional systems, known as lock contention, that occurs when large queries are being run or data is being modified. Because they are not used as transactional systems, they are able to avoid this common problem. And data warehouses provide a way to consistently present an organization information so long-term correlation is possible. They improve the quality of data, fix bad data, and can remove repetitive data so analysts and data scientists can more easily conduct their operations. And of course, they speed up the decision process. In order to provide these capabilities, the environment will need to be properly structured. But even with the environment, there are a few different structures that can be used. Something to remember is that, just like a regular database can be structured in a variety of ways, a data warehouse can also be structured in different ways. This is often determined by the organization and also by how the warehouse is going to be used. A typical environment is going to contain one or more source systems used to provide data to the data warehouse. These can be transactional databases or even other types of systems. There will also be some type of physical architecture used to store the data. In Facebook and Google's case, these are incredibly large systems or groups of systems that store many petabytes worth of information. Each architecture will also have a set of tools or applications that users can operate to pull the data that they need. We touched on a few of the applications in an earlier lecture, but now is a good time to dig a little deeper into those. These are some of the different applications used by analysts to extract the data in a format that they need. This could be charts and diagrams, plots on a map, custom script execution, or many other options. Splunk is one tool that can provide visuals of data analysis to make it easier to look at the results of queries using charts and diagrams. These look a lot like what you might find in Microsoft Excel, except that they display a lot more data. ArcGIS is another type of application that provides a graphical view of geographic map data. It's quite a unique tool that a data scientist could employ to display events happening in different locations. I have seen some work that plotted Twitter activity on a map during a major world event, and it was very interesting to see the correlations. One other fairly popular application is Scriptella, which is a script execution tool that provides some data management capabilities such as migration, import, export, schema upgrades, and executing scripts in SQL and JavaScript. Many of these applications are in competition with each other, so you will see that some offer different capabilities, but within reason, much of what they offer is the same. I would be remiss in this lecture if I didn't take a minute to introduce you, at least digitally, to Bill Inman, who is known as the father of data warehousing. Mr. Inman has more than 3 decades of experience with database technology and designing data warehouses. He has developed methodologies for data integration and structured data that has become the standard in data warehouse architectures. Mr. Inman has also done extensive work in the government sector, and many of his books, technical white papers, data models, and articles are used worldwide. It is visionaries like Bill Inman that have allowed data warehousing to grow into what it is today, and even though data warehouses have been around since the 1960s, his work has brought about many key developments in this field. Okay, hopefully you now have a really good understanding of a data warehouse. These warehouse environments are needed to manage the massive amounts of data currently being collected by organizations all over the world. These huge relational databases are used by online giants like Facebook and Google, government organizations like the National Security Agency, theme parks, oil companies, large business enterprises, and pretty much anyone else you can think of that has a need to collect these levels of information. It's actually quite fascinating when you dig deep into the world of data collection, but it can also be overwhelming. Next week we will get a little more into the details of how to design a warehouse for use in an organization.